Okay, so question number 2 in your review assignment number 2 from your previous class, we need to go over stoichiometry again. So many of you, I think, probably remember how to make a chemical equation, how to assemble one, and how to balance. And it's stoichiometry is the area of chemistry where we're dealing with amounts of substances involved in a chemical reaction. So if we're given an amount of one substance and it's fully reacted, we can calculate the amount of all the other substances that are involved in the chemical reaction just by given one thing. So here's our chemical equation. We're actually given the chemical equation, so I'm just going to rewrite that here. You'll have this in your assignment notes, but I'll rewrite this. So we need to make sure that this is balanced. Okay. So this is a properly written. What type is this, by the way? What type of reaction?
Single replacement?
Not single replacement. No.
Decomposition.
Decomposition. Very good. It's a decomposition reaction because we have one thing breaking up into smaller parts. Okay? Thank you. Good. All right. So is it balanced? Well, we have one sodium on this side. We have one on this side. I have one chlorine on this side. I have one chlorine on this side. I have 3 oxygens. I have, 2 oxygens. That's not going to be any good, is it? So let's balance our oxygens. I think it would be what we could do. Now this is what you could do. This is one way of doing this. If all you have to move is oxygens and we have oxygen all by itself over here, what you could do is you could go like this. Multiply this by 3 over 2 and that gets, when we multiply this out, that gets 3 oxygens. The only problem is we don't like fractions in our balanced equations. We have to have whole numbers. So right now it's balanced. If you just do that, right? Multiply 2 by 1.5 gives you 3. But we don't like ratios, so I'm going to multiply everything by this denominator, everything by 2, and that's how we get our balanced equation. That becomes 3. Now if you don't like doing the fractional method there, and again I don't want to focus too much on balancing, but if you don't like that, you could say, okay, I need, let's get a common amount of oxygens. I'm going to multiply this by 2 and this by 3. That's a totally fine way of doing it too. You would also notice that this too affects the sodium and the chlorine, and those can be balanced just by putting a 2 there, and you get the same result. Okay? So balancing equations, you've got to know how to do that. All right, in the stoichiometry example, we are asked to calculate the mass of oxygen gas. So guess what? We're trying to find this oxygen gas here. And I'm just going to bring that down for a second so you can read that. We're trying to find, and this is the way I do this stoichiometry, okay? I map it out. And you might recall, if you were in my class here leading up to Chem 30, you might recall this sort of stoichiometry method of mapping it out. So we're given 145 grams of sodium chlorate, and so that's 1, 4, 5 grams, and I'm going to put that right underneath this. So now that we're given this, and we're asked to calculate the mass of oxygen over here, mass of oxygen, I need to figure out how I can go from given this over to here. But as you might recall, when we're dealing with a chemical equation, these numbers, these ratios right here are molar ratios. They are not ratios of mass. So we have to convert everything to moles first. So in the notes here, here's your notes for question number 2. Find the moles of sodium chlorate by dividing 145 by the molar mass. Okay? All right, so we have to convert whatever we're given to moles. So we cannot go directly from grams to grams. Instead, we have to go down here to moles. All right, so if we add up all of the molar masses from our periodic table, and as some of you maybe have done this already, so I'll ask you for the number in a second. We need sodium, so we need to add this one, 9898, I think, 98987, plus chlorine, which is I think 35.4527, right, plus 3 oxygens, right? So we need to add up all those together to get the molar mass of this. And who's got that molar mass there? Just shout it out.
106.4406.
Thank you. And that's grams per mole here, okay, of NaClO3. So when you add up the molar mass, again, straight from the periodic table, 106, we're good with that? Does that sound good? 22, 35, and 45? Okay. So you divide this, and what did you get? Did you get the moles there too? Some of you are partway through that question. What did you get? 4.4? 1.4. Okay, is there more decimals or you just write that down? Okay, 1.4. Okay, so we'll keep as many decimals as we can in the question. There probably are some more decimals, but it could be 0, 0 or something. So whatever the decimals are, we'll keep as many of them we can. And we're going to give our answer in 3 sig figs as we're given a measurement here of 145. Okay, so the final answer should be in 3 sig figs when we're done. Significant figures, if you recall that. So, do we have more decimals here now or no? Anybody try that again?
1.36.
Okay. 1.36226. Okay, so again, that's just a word of caution there. Try not to round too early in the question. Keep all the decimal places that you can until the very end. Because if we do several calculations and we're rounding them to 2 sig figs right away, we're going to be way off at the end. So keep those decimal places. Good. All right, so this was the question that sparked this conversation because the notes here say, now use the balanced equation to find the corresponding molar ratio, okay, of these two things now. So use the ratio. So what does that mean? Well, that means now that I have to focus on these two numbers, okay? So the ratio of moles of sodium chlorate to oxygen in this equation is 3 oxygens for every 2 NaClO3s. All right? So what I have to do is I have to make sure that this ratio of 2 to 3 is the exact same down here. And so what you have to do is convert this to moles of O2. Okay? So we use the ratio. And if you recall, the easiest thing to do is multiply this number by whatever this number is in the balanced equation divided by whatever this number is. So what you're going to divided by what you're coming from. So multiply it by 3 over 2. And that makes sense because 3 is 1.5 times 2. So you're going to multiply this by 3 over 2. Okay, so I'll just get out my calculator here. And 1.3626 times 3 divided by 2. We'll just do it straight like that.
1.36226.
Oh, 226. I missed a 2 there. Thank you. So let's get back to that entry and let's add a 2 there. 1.36226. We're good there?
Yeah.
That is okay. We're all agreed. All right. So let's try that again. 2.04339. 2.04339. 2.04339. Okay? So that was, I think, the question that you had over there, right? Right? Okay. So use the molar ratio. Multiply by whatever it is, the number you're going to, divided by the number that you're coming from. That's the easiest way I can tell you to put that. So that this 2 to 3 is the same as 1.36226 to 2.04339. That's the same ratio. All right, so we're almost done. The reason why I put this blank here at the beginning of the question is to say, hey, this is where we need to end up. So we're given grams, we went to moles, we went over to moles, and now we have to go back up to grams. And so if you recall, I don't know where I put that, really. But the conversion chart there, remember that conversion chart? So that would have been perhaps on this screen. Yeah, right here. Right? So we got to go moles up to mass, grams. So we multiply by grams per mole. Okay? So multiply by grams per mole. Now, what you want to remember here too is that this coefficient 3 is now no longer involved in our calculations. It's only for moles to moles. We do not include the 3, and this is a common mistake that I've seen over the years, that students, when they're calculating grams per mole, they'll go 3 times 2 times 15.999. No, this 3 is now a non-factor. Okay, so we got to do this. We got to do times 2. You do use this number, of course, times the molar mass that's shown on the periodic table of oxygen. All right, so that's close to 32. So let's get this number, and we'll leave that on our screen. I won't retype that. I'll just go times 2 times 15.9994. 65.386. 65.386. And again, At the very end, so now that we've got our grams of oxygen involved, at the very end, now is where we want to take a look at our significant figures here and say we've got 3 significant figures. That's the lowest number of significant figures that we used in our calculations. So let's make our final answer rounded to 3 sig figs. So that would be 65.4 grams.
Do we need to say like grams of O2?
To be complete, if you put O2 there, that'd be great. Yeah, that would be awesome.
We won't use math.
No, it's fine. If you don't, no, just 65.4 grams. Make sure you have your units there. Okay, that's fine. I'm looking for mass of oxygen, so I know what you're talking about. But yeah, you should put right sig figs and units for sure. All right. Any other questions about that? That's a typical stoichiometry question. That is not including limiting reactant. Okay, and that's where we kind of ended in our last class, was taking into account another reactant that we're given an amount of, which that's a different type of question, which we might do today. But that's a basic mass to mass stoichiometry question. Good?